Thank you for your interest in our study assessing the potential of plasma kisspeptin as a biomarker for miscarriage. In addition to its more well-known hypothalamic role in regulating GnRH secretion, kisspeptin is also produced in high amounts by the placenta. Kisspeptin is expressed by syncytial trophoblasts, whilst its receptor is expressed in both cyto and syncytial trophoblasts. Thus, kisspeptin is hypothesized to play a vital paracrine role in the regulation of placentation. Indeed, application of kisspeptin reduces trophoblast migration by 70%. Miscarriage affects 1 in 5 pregnancies, but assessment can be challenging and a prolonged duration may be needed before a confirmed pregnancy outcome is reached. To date, there are no biomarkers in clinical use that can assist in this process. And whilst there is some evidence for kisspeptin as a biomarker for miscarriage, a recent editorial in Fertility and Sterility had suggested that more data is required. Therefore, we recruited pregnant women who presented to our early pregnancy assessment unit during the first trimester either to seek reassurance or after experiencing symptoms of possible pregnancy loss. Intrauterine pregnancy was confirmed at first assessment, and women were then invited to attend every 2 weeks during the first trimester or until pregnancy outcome was confirmed. An ultrasound scan was performed at each visit, and a blood test was conducted for plasma kisspeptin and beta-HCG levels. There were no significant differences in the baseline characteristics of 265 women with healthy pregnancy and 95 women who suffered miscarriage. Using a multivariable linear regression model, we evaluated the baseline characteristics that contributed to the intersubject variability in plasma kisspeptin levels in women with healthy pregnancy. Gestation and maternal age were associated with higher plasma kisspeptin levels, whereas Afro-Caribbean ethnicity, smoking during pregnancy, and BMI were associated with lower kisspeptin levels. Plasma kisspeptin levels increased linearly with gestation in control pregnancy, but were markedly reduced in women who suffered miscarriage. A multi-level adjusted logistic regression model determined that the odds of miscarriage were reduced by 35% for every 100 picomole per litre increase in kisspeptin levels. Due to beta-HCG's quadratic profile, it is more challenging to differentiate healthy pregnancy from those affected by miscarriage, especially at late first trimester gestations. Indeed, the performance of kisspeptin and beta-HCG was similar prior to 8 weeks of gestation, but whilst that of kisspeptin remained high after 8 weeks, that of beta-HCG fell. Indeed, a single measure of these two markers could widely disperse the risk of miscarriage, such that an above average level of kisspeptin and beta-HCG was reassuring, with only 1% of women having miscarriage, as opposed to 94% of those with lowest values. Further, kisspeptin levels were even lower with closer proximity to the time of miscarriage confirmation, and in women with complete miscarriage than those with incomplete or missed miscarriage. We used only the sample at first presentation to produce a decision tree which shows the probability of miscarriage in the red boxes. The complex decision tree on the left had an accuracy of 87% for correct prediction, but could also be susceptible to overfitting. Thus, we also present a simpler parsimonious decision tree on the right, which still had a diagnostic accuracy of 83%. So in summary, kisspeptin is a promising biomarker for assessing miscarriage risk and provides additional predictive value to beta-HCG, especially at late first trimester gestations. On behalf of all of the authors, I thank you for your interest in our work.